Hey, Miss Lemons, how are you doing? It's sure good to hear from you. Uh, First of all, ratios are one number, doesn't have to be a number, it could be a word of some kind, is to another number. For instance, if you have um, apples to oranges, if you have apples to oranges, and you want to know what is the ratio, if it's apples is to oranges, it's apples is to the fraction bar means, remember we talked about this a lot, the fraction bar means divided by, it also means is to oranges. Or if you said oranges is to apples, okay, that one would be oranges is to apples. This is going to be in the numerator or the top number, and this is going to be the bottom number. Now, if we're talking about, let's say men is to women, let's say that there are 15 men in a class and 20 women, OMEN. What is the ratio is the, and you can tell my handwriting hasn't gotten any better over the years. I'm sorry. Uh, 15 men and 20 women. What is the ratio of men to women? Okay. Men is to MEN. So it would be 15 is to 20. Now we can reduce this fraction because they both end in 5 or 0, so we know that they are divisible by 5. So it's going to be 3 over 4, which is also 3 divided by 4, which is 0.75 or 75%. Okay. Let's see. Now, what if we said, what is the ratio of women to men? Women and men. That would be 20 women is to, remember the fraction bar means is to uh, 15, which is, and again, we can reduce the fraction, which is 4 over 3, which is 1.3 repetend, I think, which is 130, no, 133.3 repetend percent. Remember, move the when you if you're changing it to percent, you move the decimal point to the right 2 times. Now we also will show ratios like this: women is to men. It can be that way also with the colon here. Or men is to. This means is to. Don't see this a whole lot, but you will see it from time to time. Same stupid thing. Now this is where you stop and get you a drink of your Diet Coke. Oh, that's good. Okay. Ratios are really very simple. It's just one of those things where the definition of the terms of the words are kind of unusual and like that. Okay. Now proportions. Proportions are something that you might actually use in real life. P-O-R-T-I-O-N-S. Hope I'm spelling that right. Proportions basically are ratios. Let's say that, let's see, come on, stupid, think. Let's say that apples, let's say 5 pounds of apples are $3.50. How much would 3 pounds cost? Okay, it's a simple proportion. You can set this up any number of ways. It's a again, it's a ratio, and what we'll say here is if 5 pounds is to 350, okay, we have pounds up here, money down here. Is 3 pounds is to, we don't know. Now you can also do it pounds is to pounds as dollars is to dollars. It doesn't make any difference, but you just have to be consistent. Excuse me. You just have to be consistent with how you do it. Now, how do we solve this? Very simply, cross multiply. So this is 5x equals 3 times 350. Okay, cross multiply. So we get 5x equals, I'm sorry, I've been away from school for over a year, so my skills weren't very good to begin with. 350 times 3, what is that, 1050? Yeah. Was that right? 1050? I think so. Now, how do we solve this? Very simply, we have 5 times x and multiply. So how do we undo multiplication? Is division. Divide this side by 5. Divide whatever you do to one side, you have to do the other. Divide this side by 5. 5 divided by 5 is 1x, or just x, equals $2.10. Okay? Now, you have to ask yourself, does it make sense? Is it reasonable? Now, this is 5 is to 3. 3 is a little more than half, right? A little more than half of 5 would be 250, but it's kind of close to, kind of about half. And what's half of 350? $1.75. So is this close? Yeah, we're probably right. Okay, let me do another one of those. If 10 pounds of Tide, TIDE, is $11. Hmm. You know that's not right. How much would a 7-pound box of Tide cost? 7 pound of Tide would be how much? Again, now I'm going to do this one a little differently. We're going to do, but you can do it either way. Up here we did pounds is to dollars, as pounds is to dollars. Now we're going to go pounds is to pounds. But you can do it either way. It doesn't make any difference. Okay. 10 is to 7. 10 pounds is to 7 pounds. As now we're going to do the dollars. 11 is to how much? Now the one thing you can't do is you can't do 10 pounds is to how much. You have to be consistent here with how you do this. You have to do it the same way each time. Again, we cross multiply. 10x equals 77. Okay, divide by 10. So x is $7.70, I think. Does it make sense? Is it reasonable? This is just a little bit less than, or this is almost a dollar per pound. So $1 per pound here would be about $7. So yeah, we're probably right. I hope that makes sense. And again, you could do this. Let's do it the other way we did it. The other way. We did 10 pounds is to $11. Okay, pounds and dollars. As 7 pounds, again, you have to put pounds up here, is to, we don't know. So this would be, we cross multiply, we get 10x equals 77, divide by 10, x is 7 point. Well, not 50, dumb, stupid boy, 770. Okay. Again, the secret to doing proportions is do it the same way on both sides of the equation. Here we did pounds to dollars. Here we did pounds to dollars. Up here we did pounds to pounds. And here we did dollars to dollars. Okay, that's proportions. Now the next thing you had on your list were conversions. And I'm sorry, but I'm just not sure what you want to convert there. But probably you would use a proportion. You want me to do another proportion? Yeah, they're pretty easy. Even I can do them. They're so simple. Let's say, let's see, gas. Let's say gasoline is, no, that didn't work. Look how old my hand is. Oof, that's an old hand. Come on, stupid, think. Okay, a gallon of milk. No, say 3 dozen eggs. 3 dozen eggs cost, or what is it anymore? But $7.50. How much would 1 dozen eggs cost? No, let's not use a 1. Let's use 2. So 2 dozen eggs cost how much? Again, we set up a proportion. 3 is to 7.50. Okay, dozen to dollars. And on this side of the equation, the same thing. 2 dozen is to how many dollars? Cross multiply. We get 3x equals, what is that, $15? I think. Divide by 3, x is $5. Now, does it make sense? Is it reasonable? These are pretty close to being the same to each one. Well, $7.50 and $5. This is should be a little bit less, and sure enough, it is. So we're probably correct. Proportions. Now fractions. Let me do the multiplying and RACTI fractions. If you're going to multiply fractions, that's the simplest thing you can do with a fraction. You don't have to have a common denominator, none of that stuff. Let's say if we have 2/3 times come on, stupid, 4/7. Multiplying fractions is very, very simple. Just multiply straight across. 2 times 4 is 24. 8. And 3 times 7 is 21. Can we reduce this? No. So that's the answer. Fractions, when you're multiplying fractions, again, it's the simplest thing you can do. You don't have to have a common denominator like you do with adding and subtracting. And then if we have 3/4 times 2/5, 3 times 2 is, was it 6? Yeah, I knew that. Over 20. Now both of these are even numbers, so you know that they're divisible by 2. Divide this one by 2 and we get 3 over 10. Now if they'll let you use a calculator, if you have this calculator, almost all of them have this. What am I looking for here? Calculator, right up here. Calculator. Now, remember the fraction bar means divided by. So if you have 2 divided by 3, you know what? I think the best thing to do here is use parentheses. Open parentheses, 2 divided by 3, because this thing will do order of operation for you. Close. Times 4 over 7, open parentheses, 4 divided by 7, close parentheses, is 0.38. Let me see. You can convert this to, well, a lot of the calculators will have hmm. A lot of calculators will have a conversion where you can convert it from decimal to fractions or vice versa. Okay. Now dividing fractions. Okay, I hope this made sense here. It is really, really simple. Just multiply straight across, multiply the numerators, the numbers on the top, and then the denominators. Now, if you're dividing fractions, how do you do that? You don't divide fractions. If you have 2/3 divided by 4/7, same problem we had here. Okay, how do we divide fractions? Again, we do not. We multiply by the reciprocal. Reciprocal means just flip this number, or this one, not this one. So it's 2/3 times 7 over 4, which is 14 over 12. Again, both of these are even numbers, so we can divide by 2, 7 over 6. Okay, again, how do you divide fractions? You don't. You multiply by the reciprocal of the denominator. It sounds like some kind of disease, doesn't it? Multiply by the reciprocal. The reciprocal means just flip it over. Okay, so again, let's take this one that we had up here. 3/4 divided by 2/5. Again, how do you divide fractions? You do not. You multiply by the reciprocal. So this is 3/4 times 5 over 2. Okay, we take this one and flip the numbers over. Take the reciprocal. So that's 15 over 8. This cannot be reduced. Okay, that's all there is to it. Now, adding and subtracting fractions, this is a little more difficult because you have to have a common denominator. Take a drink of your Diet Coke. Let's do a real simple one first. A half and a half is a whole, right? So what we're going to do here is, if you'll notice, these are ratios. So let's cross multiply, or proportions. I'm sorry. So that 2 times 1 is 2 over, and 2 times 1 is 2 over. Now what you do to get a common denominator, we're going to multiply the two denominators. Okay, cross multiply to get the numerators, the top numbers, and to get the common denominator, we're going to multiply these two. So that's equal to 4 over, and you don't add, excuse me, you don't add the denominators. You keep these the same for both. And 4 over 4 is 1. Now, if you have 2/3 plus, now the procedure for adding and subtracting fractions is exactly the same, except of course you're going to subtract the numerators rather than multiply. 2/3 plus 3/4. Again, cross multiply. 4 times 2 is 8 over, and 3 times 3 is 9 over 12. Okay, now if you want to, you can leave this the same, and you're going to get 17 over 12. Or if you want, you can reduce these fractions. It'll come out to be the same thing. 8 and 9, 17, 12 and 12. You don't, again, when you're adding and subtracting, you do not change the denominator. It stays the same. Okay. Let me do another one of those. Don't you love fractions? Now again, oh, and remember, to get the common denominator, you multiply these two. Take a drink of your Diet Coke. Oh, that's a good Diet Coke. Now, what if you have a mixed number? Mixed numbers like 2.5 plus 3 and I wish you'd think 2/3. Now, what you do here is you change this to an improper fraction. Well, not improper, a mixed number to an improper fraction. And the way you do that is multiply these two and add the numerator. 2 times 2 is 4, plus 1 is 5 over 2, and the denominator stays the same. Plus, again, 3 times 3 is 9, plus 2 is 11 over 3. Now, do we have a common denominator? No. So you have to make these into something with a common denominator. So again, cross multiply. 3 times 5 is 15 over, and then you multiply these two to get the common denominator, 6. Plus, what am I doing here? Oh yeah, 2 times 11 is 22 over 6. We have a common denominator, so now we just add the numerators. So that's what, 37 over 6. And if you want to, you can remember, this means divided by. So 37 divided by 6, and that'll change it back into an improper, a mixed number. Okay. And subtracting is exactly the same way, except you're going to subtract the numerators instead of adding them. Okay. Okay, here we go. Now, what if you have 2/3 minus 1/4? Again, cross multiply. 2 times 4 is 8. That's going to be in the numerator. Over 3 times 4 is 12. Now, what you can do is just put them all into the same fraction bar. Minus, okay, 3 times 1 is 3. Now we have a common denominator. Now, you can also do this 8 over 12 minus 3 over 12. You can reduce the fractions if you want, but there's really no need. Is 5 over 12. Okay? And again, if we have a mixed number, 4 and 2/5 minus 2 and 2/3. Okay? We multiply these two, and then we add that. 5 times 4 is 20, plus 2 is 22 over 5, minus, again, multiply these two. 3 times 2 is 6, plus 2 is, I hope my arithmetic is right, over 3. Oh, wait, stupid boy. You have to multiply the two denominators. That's 15. This will be 15. I'm sorry. I'll do better. Okay, so we do 22 minus 8. What is that? 14? My brain's gone numb. Okay, first you turn it on. 22 minus 8 is, 14. Oh, it's amazing. You take a little break from this stuff, and boy, you get away from you quick. Or does me anyway, because I'm stupid. You knew that. Okay? And that's it. That's all there is to it. Okay, I sure hope you do well next time you take this. Um, if there's anything you want me to go back over or redo or whatever, please let me know. I have nothing else to do but cry myself to sleep for my nap. I'm not teaching this semester, so, or the first half of the semester anyway. Okay, take care, Ms. Lyons. Again, it was good to hear from you. You take care. Bye-bye. Bye, Bonds.